everyone, and welcome to the .NET Core Podcast, a podcast where we reach into the core of the .NET technology stack and, with the help of the community, present you with the information that you need in order to grok the many moving parts of one of the biggest cross-platform multi-application frameworks on the planet. I am your host, Jamie Waffling Taylor. In this episode, I talk to Steve about what dependency injection is, what inversion of control is, what an inversion of control container is, and how to leverage the built-in IOC container provided with .NET 5 to more loosely couple your applications, making them easier to test. This is actually the second time that Steve has been on the podcast. The first time he was on the show was in episode 49 when we talked about configuration in .NET Core. There'll be a link to that episode in your podcatcher in case you want to listen to that. So let's sit back, open up a terminal, type in .NET New Podcast, and let the show begin. So, thank you ever so much, Steve, for agreeing to be on the podcast again. Welcome back.
That's my pleasure. Yeah, thank you.
Welcome back. You're in a very esteemed club. There's only you and Steve Smith, I think, at least at the time of recording, who's been on the show twice. And
just need to get Steve Gordon back, and then it's a triumvirate of Steve's taking over the show.
I like it. Maybe we should have a special episode with you three on it. We should call it that.
It's a bit like the Three Scots. I'm one of the lesser Steves.
That's it. The three Steves. I like it. Excellent. Okay. So like I said, you were previously on the show, and I think it was episode 49 when we talked about config stuff, because I think that was shortly. I want to say it was after when we were at DDD North together. No, it would have been before.
I think
DDD
it was just
North.
Before we were at DDD North.
That was it. Yeah, because you gave the talk there, didn't you?
Yeah, I did.
Week.
Yeah.
Yeah. Excellent stuff. I do remember there was some really cool stuff about dependency injecting your config stuff.
Yeah, so that's what sort of kind of led me on to sort of looking more into DI a bit more. So been digging in a bit more, and hopefully got some information to tell people.
Fantastic. So for the one or two people who are maybe catching this episode and haven't had a chance to listen to episode 49, by the way, if you haven't heard it, definitely go back and give it a listen. There's some stellar stuff in there, and it's well worth a listen, because that might sort of help inform some of the things we talk about, and it might be that, the points you raise here will sort of maybe answer some points that we came up with last time. I'm not sure, but definitely go check that out. But for the folks who haven't done that, could you give us a brief sort of quick introduction so that they know who you're talking about?
Yeah, sure. So I'm Steve Collins. I'm a developer based in the UK. Been working with Microsoft technology since the early 90s, started with VB3, but last sort of few years been working on .NET and then .NET Core, and just lately been delving into .NET 5. So I tweet at Steve Talks Code, and I've also got a blog site at stevetalkscode.co.uk.
Excellent. I think that's going to be one of the strange things about the podcast going forward, is because of what I call the pod time cast machine wibbly wobbliness. We're recording this only a few weeks after .NET 5 was officially sort of released to the public. It had been released as release candidates beforehand, but it's now official .NET 5.
Yeah.
And it's left me wondering about the future of the name of the podcast.
I did wonder.
So, when people listen to this in the future, they're going to be like, .NET Core? So, maybe you're hearing it here first, folks. Maybe it'll be the core of .NET. I don't know. The core.NET show or something. I don't know. I don't want to be stepping on .NET Rox's toes, but maybe I need to. But there you go. I don't know. Not that I could. I could maybe step on the tiniest of the toenails. That'd be it. But yeah. So for context, for anyone listening, we recorded this, like I said, only a few short weeks after .NET 5 was officially released. So there might be a couple of things that I say, hey, well, with .NET Core, what I now mean is, hey, with .NET 5. So, take that with a pinch of salt, everyone. And obviously, because of the whole on-demand thing with podcasts, you all can listen to this whenever you want. If you want to wait 4 years and listen to it, then you can. But
.NET 10.
I know, right? But there you go. Excellent. So
Or would it be
yeah.
.NET X by then?
Oh, that's good. Yes. Or would they? You see, now you've got me wondering how they would do it, because maybe it would be .NET X, and then 10 years later it would be .NET OS.
.NET Cappuccino.
Ooh, I like it. Yes, start naming the .NET version numbers after different drinks you can get at Starbucks. This podcast is not brought to you by Starbucks, but I like that idea. Anyway, right. So we're going to be covering a couple of the couple of the points from a talk of yours recently about dependency injection, and I figured, because a lot of people get these sort of terms mixed up, muddled up, sometimes confuse them a little bit. I was wondering, could you quickly talk about the relationship between like dependency injection and inversion of control? Because I have an idea of what it is, and you may have an idea of what it is, and the listener may have an idea of what it is. And guess what? Since they're all opinions, they're all right, because opinions can't be wrong, right?
Do not take mine as a definitive. Go to someone like Martin Fowler for the definitive. But yeah, sure. It does get confusing, doesn't it? Because you've got inversion of control, and then you've got dependency inversion in solid, and then you've got dependency injection. It all becomes a great big sort of alphabetic soup of all these terms that all sound a bit similar. But yeah, so inversion of control and dependency injection, I think of sort of a bit sort of yin and yang, in that inversion of control is sort of a design pattern or concept where instead, when you say, I need an instance of something, instead of newing it up yourself, you say, I'm going to rely on someone else to give me that instance. So you mentioned Steve Smith in the introduction, and he has a phrase of new is glue. Because then if you knew something up inside your class, you are stuck with it. You made that concrete. Whereas if you can say, I want someone to give me that instance, how they give you that instance, well, that's kind of up to them. That's kind of where dependency injection comes in. So inversion of control says, I'm not going to do this myself. I want someone to give it to me. And dependency injection comes along and says, and here it is. And where dependency injection is nice, in that if you want lots of things and things have got interdependencies, it will go and marry up all that hierarchy together and say, yes, I'll wire this all up for you, and ta-da, here it is.
Sure, okay. I mean, that makes sense. So my sort of, the way that I always think about it is very similar to how you've said it, is that I think of IOC as kind of like an interface to dependency injection, in that, it doesn't define how it should happen. It just defines what should happen. And then dependency injection comes along and says, cool, yeah, I'll hide the implementation from you. But when you say, like you say, when you say, give me a new instance of something, don't worry about how it gets there. I'll figure that out. Here's the new instance, right?
Yeah. And that's where dependency inversion in solid kicks in, because dependency inversion takes those principles, but it adds in the layer about abstracting out and saying, use interfaces, use abstract classes, not concretes, because then you can swap them around. It becomes all testable. And then the one that's always touted is, I'm going to change from SQL Server to Oracle, and no one ever does.
Yeah.
But that's the kind of example that's always touted in examples.
Mm-hmm. Yeah, I once worked at a place where, I once worked on a project where they said, we want interfaces for everything, right? We're going to use .NET Framework, but we're going to wrap everything in interfaces just in case we swap from .NET Framework to Java. And I'm like, if you do that, you got a bigger problem than system.console.writeline,
Yes.
So what I'm pointing out there is that I think you can take it too far. Like if you're abstracting around the entire framework that you're using, the entire language that you're using, maybe you should rethink it. But yeah, if you're wrapping around, say, what I think one of your canonical examples is the same as one of my examples, your system.datetown.now. If you're using that anywhere in your code, then you can't test it, because now is not then, and it's not the future. It's always changing. And so you can never write an assertion against that. But let's say you're doing, I'm sure you'll come to it later on, but let's say you're saying, do this thing and get me the time. Well, if you inject the system datetime.now in through some kind of interface or through some kind of dependency inversion, then you can set that value ahead of time, and then it goes through all of your layers of complexity, and you could check it's still the same value at the end, right?
Yeah, exactly.
I'm glad I got that right. But yeah, and the other one I always think of is when it comes to like DI and IOC is like the plug sockets on your wall, right?
Yeah.
You don't have to, if you buy a lamp, right? You obviously the listeners can't see, but just off camera, I've got a lamp on my desk. In fact, if I do this, you can see it, right? I didn't have to wire that lamp into the electricity source coming into my house.
Yeah.
I take this 3-pin, because we're in the UK, 3-pin adapter, plug it into the wall and flick a switch. And all of the magic complexity of getting the power from the power station down the other end of the country, down into the street, into presumably a transformer, and then split off into my house, and then split from there to the room I'm in, and then split from there into the wall, and then from there into the lamp. All of that magic is taken away. It doesn't matter how the electricity gets there. I get that new instance of electricity, right?
And it's interesting you give that example because Steve Smith, again, he's coming up an awful lot this episode. He used to do I think, I've forgotten what it's called. I think it's called the Calendar of Code or something. And one of the months was about abstractions. And the example was the 2 wires from a lamp going straight into the electricity socket without the plug.
Mm-hmm. Yeah, it's a wonderful example. And I sometimes, when I was at university, one of my lecturers, Rob Miles, gave an example of an MP3 player, right? When it comes to abstractions, this is not dependency injection or inversion of control, but a brilliant example he gave was, this tells you how long ago it was, right? I have the MP3 player, I have my headphones plugged into it, I push play and sound comes out the speakers. That's all I need to know. I don't need to know that when I push play, it starts a file stream, it loads the bytes in, it then does decompression to convert it from MP3 into presumably some kind of wave or something, and then it does amplification, and then it does signal processing, and then it sends it over to the sound chip that then does a whole bunch of magic wizardry to turn it from a digital signal to an analog signal, and then it sends it down the wire where it gets to all of that stuff's taken away because you push the button, you get the sound, right?
Yeah.
Abstractions are great.
Abstraction is a beautiful thing.
Exactly. But anyway, we've said all of that, and we haven't really talked about anything about what we're actually going to talk about. But that's what I think is great about the sort of tech space, right? You could say, right, let's go with this sort of almost canonized dictionary definition of something and talk about the very intricacies of how it's supposed to work. Or you can say, look, we can do that, or we can talk about any kind of metaphor or whatever that just, oh my goodness, how long ago was it? There's an early episode of the podcast where I talk about using metaphors as a way of getting the point across. And it's great because everyone listening will have understood because they've just done it to listen to this episode. They've pushed play and they've started listening to the show, and it's coming out of speakers, it's coming out of headphones. It fits, right? Why not use metaphors?
Yeah, I love metaphors. So sometimes I take them a bit too far, but
yeah. As long as everyone knows that it's not exactly like this, but this is kind of a way to get you to understand how it works, then it works, doesn't it? Right? Okay. So I was worried that talking about inversion of control and dependency injection would complicate things a bit, but I mean, we're both quite experienced in the technology sphere. Hopefully the folks who are listening get the idea that they are subtly different, but one is almost like an implementation of the other. Yeah. And I feel like hopefully we can go on from there. So
to use another metaphor, I think of it a bit like a jigsaw puzzle where one side's got the hole and the other side's got the bit that juts out.
That's it. Yeah.
And like your electrical example, one plugs into the other.
That's it. Yeah. So then in that case then, so I feel like I know the answer to this one because I've been using ASP.NET Core, or I suppose is it ASP.NET 5 now? I haven't really.
I think they're still calling it Core, aren't they?
Oh, fair enough then. I mean, we'll soon be.
Who knows? By the time this comes out, who knows what it'll be?
Exactly. Send me a tweet to let me know what it's called. But so I've used ASP.NET Core to build a whole bunch of stuff, and I happen to know that if I put whatever my interface is into the constructor, I'll get an instance of it as long as I've done some wiring up. So I have this feeling that there is dependency injection inside of that. But is that dependency injection, and is it different in some way from, say, AutoFac, Ninject, that kind of thing? Or is it just, it's all kind of what's the phrase I'm looking for? So much of a muchness. It's all kind of similar solutions to the same
thing. So if we take a step back before .NET Core and .NET 5, so if we go back to good old .NET Framework, there wasn't an out-the-box solution from Microsoft. And that's when you did have these third-party and open-source ones like AutoFac and Castle Windsor, Ninject. Microsoft Patterns and Practices had Unity, nothing to do with the games engine thing. So you had all these different things. But if you're going back down to real basics, you don't even need a framework. You could create a DI thing in your own right, and it's often referred to as poor man's DI, because what you could do is just effectively have some class that sort of says, I know how to create these things and I'll do it to you. But you could tie yourself up in knots very, very quickly. It's one of those things that so that's why you sort of see frameworks come in and then die quite quickly, because it's super complicated stuff under the bonnet. And yeah, I've looked at some of the .NET Core's implementation and sort of gone, oh my, I just don't get this.
So what you're saying is that leave the PhDs to figure out compilers and DI and crypto, and we could do everything else, right?
Yeah. We'll just go along and use it. So whilst you in principle don't need a framework, it's good to have one. Now, as you say, in .NET Core /.NET 5, it's there out the box for you. Well, I say that. It's there for you in ASP.NET. Cool. It all comes part down of when you say I'm using the ASP .NET NuGet package, which comes as part of the template. That's a meta package that brings down about 101 different NuGet packages, and one of them is the Microsoft extensions .dependency injection. And within that, you'll see the startup class and so on. But if you're doing a console app, and I don't think Xamarin does it, you don't get it out. You have to go and bring that NuGet package in. That doesn't preclude you from using things like AutoFac or some of the third-party ones. Now, some of the ones I mentioned before haven't come into .NET Core world. They've sort of stayed in framework. That's because coming into .NET Core world, that particular NuGet package has a set of interfaces, iService collection and iService provider. Now, a lot of them have come along and play nicely with it. So that interface sits over the top of their ones. But they can do a whole load of things that the .NET one can't and doesn't expose through its interface. So Mark Seaman has got books and does talks about dependency injection. And he refers to the Microsoft one as a conforming container, which is a posh way of saying it's the lowest common denominator. It does the bare basics that Microsoft wanted it to do. And if you want to go beyond that, you have to go to these other container frameworks. That way you can get the best of both worlds. So if it doesn't do everything for you, you can wire one of these other ones in, but then you're managing two different frameworks if you want to do anything fancy. Now, in the talk I give, I show a few ways where you can get around some of the deficiencies of the Microsoft one. So, for example, the Microsoft one only uses constructor injection. And we'll talk about that a bit later. But fancy things like property injection and named keyed injection, these other frameworks do. The Microsoft one doesn't do it. So when I first started with .NET Core, I was bringing AutoFac in, and I was actually going, you know what? I don't actually need any of these fancy features. So I dropped AutoFac and just used the out-the-box implementation. So that's a long-winded way of trying to come around to answer. So yes, if you're in ASP.NET Core world, Yes, you get it out the box. So in your program, you've got a host that is a host builder, and that will go and create an instance of the iServices collection for you. That goes into a startup class that you write, and you have two methods on there, one which is configure services and one which is configure. So the configure services is where you do all your registrations. And then configure is once the container has been built, you can do some more stuff like adding middleware and stuff in once the container has been built. So yes, a lot of it is all out the box for you. As I say, if you go and write a console app, then you have to go and bring that NuGet package in and build the container yourself, or use the host builder to go and do some stuff.
That makes sense. I know that they'd made a few changes around it used to be, I believe it used to be Web Host Builder, didn't it? And then they changed it to Host Builder because then moving it slightly away from the web, if you wanted to bring in DI into your .NET Console app, you then had to it was weird. You had to build a web host, and it was a bit weird.
Yeah, and also it enabled you to do things like have the background services host as well, moving to the more generic host. What was interesting was when we moved from Core 2.1 into, I can't remember if it was 2.2 or it was 3 that they made that change. But what happened was on your startup class previously, you said configure services, and the signature of that had to return the service builder, the service provider that you'd have to build yourself. When it changed over, it's now a void because the host goes and calls the build on it. And that changed how some of these third-party ones, because you used to go and say, now go and build my third-party container, whereas now you have to do a couple of different extension methods on the host to say, third-party, go and build your container instead. So that was kind of breaking, it was breaking changes going from 2.1 into the later ones. Hopefully, now we're in 5 and 6 and 7, things have settled down, and hopefully we won't have many more breaking changes like that.
Yeah. Hopefully. There is another conversation, but it's something that I've been talking to other people off air about, and it's it's not for this show. We won't really cover it, but it's if .NET's going to evolve every 2 years, what's that mean for the long-term survival of your application? You know?
Yeah.
Because just putting the DI conversation to one side, we'll only cover this for another couple of minutes, but Microsoft have always prided themselves with backwards compatibility. I know of companies that are running DOS applications from the early 90s on their Windows 10 machines because first of all, it works, right?
Yeah.
And second of all, to replace it would be way too expensive.
Yeah.
But if we're looking at .NET as an ecosystem, making drastic breaking changes every 2 years, that's not going to sit well with certain projects, is it?
because even the LTS versions, you're only supported for 3 years. Mm-hmm. And your non-LTS, you're only supported for 3 months after the LTS comes out. So, exactly. Yeah. Let's hope they don't break too much.
Yeah, definitely. I mean, that's for greater minds than mine at the very least to figure out. I'm not smart enough to figure that out. Yeah. But yes, okay. So we've got this idea of a conforming IOC container system, and you've said there that maybe the built-in one provides 99% of what you need. It feels like, at the very least for me, for what I've been doing, maybe I'm not using it and stretching it to its maximum. It feels like it does almost everything I need. We'll hopefully talk about it later. We've got the different lifetime scopes, and I can inject interface. I could say to it, go make me this implementation of this interface, and I'll just pass the interface around, and it just kind of works, right?
Yeah. I mean, we'll probably come on to lifetimes in a minute, but there are things about the lifetimes which can trip you up.
Mm-hmm. Yeah, definitely. I think I got tripped up recently because I was using Entity Framework, and I was passing a service around that I had a service that used Entity Framework, and it created a repository and everything, and I was passing it around as what was it? because there's only three. It wasn't so. It was a singleton, and everything went wrong because obviously the singleton. Well, again, we'll talk. Well, maybe we should talk about it now, right?
Yeah, sure.
My understanding is the singleton lives forever,
Yeah.
and if it lives forever and it's talking to my database, then anything can attack that same database, and nothing is ACID anymore.
Yeah, I like to do the Highlander quote of "There can be only one."
I like it,
and that's how I think about singletons. In that, well, if we flip it on its head first, let's start with the short-lived one. So transients are your fair weather friends. They just come and go as you need them. So if you've got, say in ASP.NET, you've got a controller. The controller gets fired up and says, I need this business service thing. And it only needs to live for as long as I'm doing something. My controller is living. So the transient will get fired up. Controller will use it. Then when garbage collection comes along and takes away the controller, then the container will get rid of the transient and it's gone. Down the other end of the spectrum, we've got singleton that you've just mentioned. And that lives, to all intents and purposes, for the life of the application. Being pernickety about it, it's for the life of the container. So your application could live longer than container, but certainly in ASP.NET Core, that doesn't really happen. So you've got those two extremes. Very short-lived, very long-lived. Smack bang in the middle is scoped. Now, scoped, the proper technical term is you associate it with a unit of work. Now, in ASP.NET Core, what that unit of work really is the lifetime of your HTTP request coming in until the point the response has gone out. They're not absolutely bound, but that's sort of kind of the analogy of if you're working in ASP.NET, that's the way to think of it. Of something scoped will come in, will get created as the HTTP request comes in. And whereas the transient is only injected into, say, your controller, your scoped and your singletons can get shared amongst lots of objects. So say you've got several things that depend on that same object, whereas transients, each thing will get its own copy of that object, its own instance. Singletons, everything within that scope of that request response lifetime will share the same one. And singletons, everything within the whole application will get to share it. Where things get tricky is if you're depending on different lifetimes. Now, transients can depend on scoped or singletons. Scoped can depend on singletons, but the longer the lived, you can't depend on the shorter lived. So what happens is if you try injecting a transient into a singleton, if you're in development mode and debug mode, you'll get an exception thrown saying you're not allowed to do this. But that's not the whole story. That is only when you're working with when your environment is set to development or in debug mode. If you're in production, what will happen is it will merrily inject that transient into the singleton at the time the singleton is created. And it becomes what's called a captured dependency. Because what it'll do is it'll freeze it. And in my talk, I'll give the example of an insect inside a lump of amber. Because it's just encased at that point in time. So that transient suddenly becomes a singleton. And likewise, if you inject it into a scoped, it becomes a scoped. So it all gets a bit messy. So when you come to register things, you need to be aware of what your consumers may be and start registering things at the right level. But then you end up with the situation that you had, Jamie, where if you register something with a longer life than it should have, you end up with, I've got this one database call that's going to last forever.
Mm. Yeah, it never gets written to. It's no longer transactional. I mean, I have to point out, obviously, I was doing it as like you should never, because I was giving a bit of a training and I was like, okay, don't ever, what is it? The short answer I always give people is never use singleton because you're never going to need it. And then, and it's like, you remember on the TV show House where it was never lupus except for that one time that it was lupus? You're never going to need a singleton except for that one time you need a singleton. That's a bit, but that's my experience. My experience won't be the same as everyone else's.
Yeah. And I think it comes back to what things do you have talking to each other? What is that unit of work? Is your unit of work just my controller? Is it includes the things I'm injecting to my controller? Or is it something I've got across the whole application? Now, typical ones are HTTP client factory. The factory itself is a singleton, but the things it produces for you are transient or scoped.
Mm.
Rolling. Action in 3, 2, 1.
No one calls me these days. Oh, hey, what host, Squitch?
Have you finished that big new feature for the website yet?
Absolutely.
Hang on. Oh, that's not bad. It loads pretty quickly. There's every episode on it as well.
X.
What's this button all about?
Don't push that button.
That ain't gonna happen.
No!
Nothing happened.
That's what you think. Waffling Taylors is a podcast all about video games and nonsense. Check us out on Apple Podcasts, Google Podcasts, wherever you find your podcasts, or head over to wafflingtaylors.rocks. So if you want to hear more from my brother, who may or may not be a cartoon wolf, and myself about video games and silliness, head over to wafflingtaylors.rocks, or look for us wherever you listen to audio.
And don't forget that we have tons of guests and that we've covered over 1,300 games on our show so far.
And that we have over 110 episodes to choose from, too.
Wafflingtaylors.rocks.
Cut. Print.
Was that okay, Russell?
It was sufficient. Editing now.
Okay, so yeah, that's interesting. I didn't realize that. Yeah, that's so you create you can create a Sorry, it's because I'm trying to wrap my head around that.
Yeah. So you've got a factory class
mm-hmm.
where you can say this factory is, to all intents and purposes, static.
Mm-hmm.
It's something that will just go and generate something for you. And I can pass parameters into it. And then the result of that factory, you will just go off and use. And for whatever the lifetime of however you've used the result of that factory.
Right, yeah. Yeah. So, yeah, because, see, that's the thing, right? I've hardly ever used factories. Again, we were talking off air about, I've recently got the Gang of Four, right? I've used builders almost exclusively. So factories kind of confuse me a little bit sometimes. And then people say to me, well, you could use a factory, or you can use an abstract factory. And I'm like, what, have we got warehouses now? We've got factories for factories. This is just, it's blowing my mind.
Yeah. Well, I mean, I could talk about factories now, or we can talk about factories later.
Oh, let's do it later. Give my brain a bit of a chance to calm down. But because you said there about you need to think about what your thing is going to be using, and then what your calling things are going to be using. You said that you've got your controller, you've got maybe a business service, and then maybe the business service talks to something else, and then maybe somewhere down the line you're talking to the database. At some point, you've got to figure out how those all chain together. And you've brought up Steve Smith a bunch of times. I'm going to bring him up as well.
Okay.
There's a project that he has been working on for a while called API Endpoints, which I think is fantastic for this, because instead of having like one controller with 12,000 different inject statements, 12,000 different interfaces. Maybe if you've got 12,000 interfaces, you might have to rethink your design a little bit. But let's say you've got 5 things coming into a controller, and each one of those injected services is used by a different action. Right, that's 5 things that the DI container has to then somehow magically new up for you with the correct scopes and the correct lifetimes and all these kinds of things, and all of their dependencies and their dependencies. Whereas like API endpoints make it so much simpler, because you've got almost like one controller with one action. You don't have to have it tied to that, but then you just have its dependencies, right?
And it comes back to the solid principles of single responsibility.
Mm-hmm.
Say you've got under if you're using a controller, you might have the CRUD action to create, read, update, delete. But if you've got different repositories to do the reads and writes, say you're doing CQRS or stuff like that, you're having to bring in all those different repositories just to use one thing. So I'm bringing in all my read and all my update ones just to do a read, and I don't need it. So it's back to the single responsibility principle from Solid.
Yep. Yeah, that makes total sense to me. And it's all about sort of cleaning up and making it easier to read. And like you say, bring those solid principles and make it, you've got your update endpoint that just has the update things. It doesn't need all of those other things, because then you're slowing things down, right?
Yeah.
By bloating your controllers with hundreds of different inject statements, and I keep saying inject statements, but all of the dependencies that are injected in by injecting a million different dependencies, you're going to slow down the creation of that controller.
Yeah.
So technically, you're going to see a slowdown. So just separate it all out. It all makes sense.
Yeah.
Excellent. So let's take a look. So we've talked a little bit about lifetimes. So excuse me one second. So I've brought it up once or twice, and then we talked about factories. We talked about it just before we started recording. Do I need to have read the Gang of Four? Now it's in my. I've reached this stage in my career, and I've never read the Gang of Four. Do I need to have read the Gang of Four to understand injecting and dependency control?
Not necessarily, because the Gang of Four book has been around since, I think it was the early 90s, about 92, 93, something like that. So all the principles still hold valid now. But personally, I'd say if you're coming into it now, by all means, go and read the Gang of Four book. But there's plural. The ubiquitous Steve Smith has Pluralsight courses on design patterns. But there's all sorts of resources out on the internet. There's books that are dedicated to design patterns in C#, whereas I think the Gang of Four one was Java, I seem to recall.
Like I say, I have it here. It's
the
version I've got is Smalltalk C++.
Oh,
so,
right.
I mean, I can speak C++, so I get it, but I could totally understand how.
So certainly, if you're a .NET developer, I would say go and look at Pluralsight course. Go and look at one of the dedicated C# books. I went back and read the Gang of Four book just because I'm a geeky, even though I don't really understand Smalltalk and C++, but that was a long time ago now. But certainly a lot of the principles, and I talk about them in my talk. So singleton is a Gang of Four pattern, but there's a big difference between a singleton in Gang of Four and singleton in containers. If you've got a singleton as a straight C# singleton, you have to do a lot of boilerplate code to go and say, go and create the instance, put some locks around it so that other people can't create the instance the moment I'm creating the instance. So you sort of like the lazy on there to make it thread safe so that only one thing can go and create it. Then you've got to expose a static property that says instance, that says I am the singleton, and then you can go off and do stuff. With containers, pretty much any C# object can be a singleton. But with great power comes great responsibility, to use a quote. You need to be aware of, because you've got that singleton, especially if you're using it in a website, you could be hammered by lots of different threads. It's fine if your singleton is a read-only thing and is immutable. It doesn't matter. But if you've got some state in there, like a cache or a dictionary lookup, where things might be going and adding and removing stuff, things can get pretty messy. Multi-threaded programming and race conditions, it's all big. What I'd say around that is you can put some things like thread locks in and what have you, but then all your threads start queuing up behind one another. So I would think very seriously before you've got state in a singleton. If you really must have it, then maybe go and look at some of the things that are in the base class libraries. Microsoft's got a whole load of concurrent things like concurrent dictionary, concurrent cache, concurrent property bags, stuff like that. If you've got something that's using lists and collections, maybe go and look at one of those to ease your pain a bit. But do be aware that singletons and threading do come with a cost.
Okay.
So, sorry. No, sorry. Go ahead.
I was just going to say that makes total sense. I remember there was a blog post many years ago by John Skeet. He was like, how to not do singletons. And it was like every single, like if you Google singleton in C#, it's every single one of those examples from Stack Overflow on his website. It's like, nope, that's wrong. Nope, that's wrong. No, that's wrong.
Yeah.
And you should never do it yourself because it's so difficult.
Yeah, because I think he lists about 6 or 7, and I think it was .NET 4 came out and they brought out the lazy type. That's when he said, this is how you can do it thread safe. Mm-hmm. Because lazy gives you a thread safe way of instantiating it. Because when you look in the IL, there's all sorts of weird attributes that sort of says when things can be threaded and not threaded, and all very complex stuff. Whereas I tend to use that last example where if I really must have some kind of static singleton inside a class, I'll go do a private static read only lazy blah, construct it, and it's there. But as I say, if you're going into containers, singletons very much easier than trying to do all that boilerplate stuff yourself with the gang of 4. Other patterns, so we've touched on factory and builder. So the way I look at those is that factory is everything you need to go and build that object up front. Now, where I tend to use factories with the dependency injection container is, say, I've got some old class that has just a parameterless constructor and a set of properties that I have to set. And then it might have an init method that says, now go and do all the stuff and put it together. You can't really do that with the Microsoft DI container because it doesn't support property injection. But what you can do is if you write a class where you say, I will go and get those things from the container in my constructor. Now I can go and new up that other thing, go and set the properties in it, and then return it in my create method, for example.
Right.
Well, that's also useful if you've got... So, for example, say you've got... you want to say, go and create instances of food, for example. And you now, some properties might be coming from the container, but some properties you might not know until you go and say, I want one of these. Mm-hmm. So, a restaurant app, the container knows all the ingredients to go and make a hamburger, but you don't know till runtime whether you want it 1 patty, 2 patties, or 3 patties.
Right. Yep.
I'm a 2 patty person myself.
Or indeed with cheese or with pickles yeah.
So with that, the factory method can say, I will go and get all these bits out of the container, and then it's up to you that says you can pass in some parameters to your create method, and it can then go and put it together. So That's your factory. Builder, on the other hand, is more of a continuous state, for want of a better phrase, where you sort of say, here's some foundations, and now I'm going to add these extra bits on top. So quite often you'll see them expressed with a sort of fluent syntax. And certainly in a good example is the host builder in .NET. So you'll sort of say, here's my host builder, and now I'm going to add one of these, and I'm going to add one of those, and I'm going to add some login, and I'm going to add some configuration, build. Mm-hmm. And it comes out at the end. And the .NET DI container itself is effectively a build pattern, because you've got your services collection, where you go and say services, add all these services, and then say build service provider. Mm-hmm. So there's a slight difference between the two. Now, that's where I quite like factories with DI, because you could say in your constructor of a controller, go and get me one of these. But if you're relying on some parameters that are coming from your HTTP request, well, the container won't know that. So inside your controller, you could say, well, give me the factory that knows how to build one of these things, and I will go and pass you the bits I now know from my request.
Right.
Factory, go and put it all together for me.
Right, I see.
And because your factory is just a recipe for building something, that can be a singleton, because it doesn't need to new up one of those every time, because effectively it doesn't have any state. Where things get tricky is if some of the things you're relying on in your factory coming from the container aren't singletons, then that's where things get a bit messy. But there's ways and means around that, which we'll come on to a bit later.
Sure, yeah, because otherwise you end up with that. Was it the captured?
The captured dependencies. Yeah.
Okay. So you might be thinking, well, this service I'm pulling into my singleton is transient and it will go away eventually and will come back. But no, because the singleton exists forever, effectively that instance of that transient exists forever, or at least until the singleton is gone, right?
And a good example of this is middleware in ASP.NET. Because when you register a middleware, the actual middleware itself gets registered as a singleton.
Mm-hmm.
But the operation itself, the invoke, is called as part of the ASP.NET pipeline. So if you've got a dependency and it's scoped or transient and you put it in the constructor of your middleware, then you've got a captured dependency. But because the invoke is dynamically created through reflection, you can add your transient or scope dependency to the end of the invoke signature, and you'll get the correct transient or scoped coming into the invoke. So there's a slight, so being aware of, and certainly the middleware one tripped me up very early on in .NET Core, because I was going, I don't understand, because we talked about configuration in my previous episode, and we talked about options snapshot. An option snapshot gets registered as a scoped. And I was injecting my option snapshot into it and going, but this is not changing, because I was putting it into the constructor instead of the invoke.
Right. Because, yeah, the constructor creates you, like you say, that singleton instance. And because the singleton is passing that, again, I'm just saying what I've said earlier on. It makes me sound smart. But if you've got that singleton instance of the middleware class itself, and you're passing in a transient to the middleware instance, then the transient will be, or indeed scoped, will be captured at the start of when that singleton is created, and that will be the instance you get. Whereas if you're passing it into invoke, because it's, again, I'm just parroting back, but I'm learning, right? because you're passing the instance into the invoke method, which is created at runtime via reflection, you could pass in today's, this moment's instance of this transient, not the instance that you're passed into the actual middleware. Yep. That's interesting. I think I would challenge people to go try that out. Create some kind of middleware that takes in something, maybe a configuration snapshot in the constructor, and then pass it into the invoke via dependency injection as well, and see what the differences are, because I think that's an interesting experiment to do, and to learn a little bit more about it, because I can see it in my head how it would work, but not many people learn through audio. So go do it, I guess. Go give it a try and watch it happen in front of you. That's interesting. Okay, so now you've just blown my mind in that I can have a captured dependency that's not the same as the instance dependency. Right? Oh, there you go. Right, you don't have to do it with configuration. Do it with datetime.now. Do datetime.now and pass that in to your middleware through an interface at the time of creating the middleware, and then wait a little while, pass it in the invoke, stick a breakpoint in, and compare the values. They'll be completely different. I like it. I mean, that example is useless for real world stuff, but it will give you an idea, because datetime.now always changes, right? Or does it?
Mess with that.
yeah, right.
It doesn't change in a unit test.
Well, that's it. Well, hopefully,
but that's what we'll come to.
Yeah. So, okay. So I know that this is something that comes up in your talk a little bit, and it's something that I've always fallen over, right? So we have this idea of registering these dependencies, right? So you said in your configure method, you say, hey, add this as a scoped, add this as a transient, add this as a whatever, or, add these interfaces, if you use interfaces, add this interface and point to this concrete thing, or add this interface, point to this method, which creates the thing. So what about if I have a list of things I want to add into, I register with my dependency injector, and the list is as long as my arm? Am I trapped in this purgatory of like, and add one of these, and add one of these, and add one of these, like doing it manually? Or can I just say, hey, go over here and figure it all out?
If you're a control freak and a masochist like me, yes, you will go and manually go and add them all in. But that's me. There are tools out there. I think the most well-known one is Scrutor. And what that can do is you can define rules that sort of says, go and look at this assembly and go and get all the types that match these rules and go and register them as singleton, scope, transient. Go and register, if they support multiple interfaces, go and make sure you can register them all against all the different interfaces that they support. Scrutor's got a nice thing. We talked about design patterns just now. Another design pattern is the decorator pattern. So say you've got a class that you haven't got the source code for, and you want to see all the calls being logged as they come in and logged as they come out. The decorator, what you do, if it's got an interface or an abstract base class, then what you can do is re-implement that interface or abstract, inject the original thing that you haven't got the source code for, and then it's sort of kind of acting as a proxy, but with added functionality. So as you say, you may have a method say hello, then the original thing just returns hello. But your decorator can say, my say hello says, go and log, someone's asked to say hello, go and call the thing, get the return value, log what it returned, and now return that hello. So that's another thing. Now, doing it yourself, you can do it all manually, but it gets a little bit messy. Scrutor, you've got a couple of fluent extension methods where you can effectively say, go and take this thing and go and decorate it with my thing. So there's a couple of others out there, but Scrutor is kind of the best known. I think there's a happy middle ground, depending on the size of your project. If you've got 101 different objects that do very similar things, and they'll all be the same lifetime, and they all very basic, go ahead and use something like Scrutor, knock yourself out. But if you're a control freak like me, because when it comes to trying to go, this thing's not injecting as I thought it was going to inject, then you've got that extra layer of abstraction as to, well, how did Scrutor do it? Mm-hmm. Because once you've got past the service provider and it's injecting things, you don't have a way back to the original services collection to see how things were registered. Mm-hmm. So it becomes a bit tricky. Now, I think since Core 2.2, I think there is some logging that tells you about registrations in there. But and this is why I'm a bit loath to use something like that, unless it is some middle ground where I can say, these things I really want to be in control of. These things, I don't really care. Just go and register them for me.
Okay. I mean, that makes sense, right? We're all about productivity. We're all about trying to make things easier. There'll be something out there that automatically does it. But I think I fall into the camp similar to you of a case of, it can be a bit annoying to have to go .add transient of this to this, .add singleton of this to this, and .add this or .add that. But again, at compile time exactly which scope that all, I keep saying scope, I feel like it's more lifetime, but at compile time what the lifetime of that injected dependency is going to be, right? So that you can have in your mind, right, I'm injecting this as a transient, so which means that these things are going to live for as long as that thing, or I'm injecting one great big whacking singleton and I've got all of these things, so these things are being injected in and they're not going to be the same instances of those things over there. And you can make that decision, that sort of informed decision ahead of time. Is that a good idea or is that not? Because there will be legitimate cases, I guess, where having a singleton makes sense.
Yeah.
Okay. And I guess perhaps these automatic libraries, they probably do the best they can to figure out what it needs to be. And sometimes, machines get it wrong sometimes.
Yeah. I think it comes down to how you define the rules of how it's going to, and I think you're going to have some edge cases where you might have conflicting rules, so something might get registered twice, and yeah.
That's fair enough. And I mean, like, what I tend to do with my code is I'll have loads of extension methods all the way down, right? So I tend to build an extension method onto, I think this is more .NET Core 2 to lifetime, but the iServices provider for when you're injecting your services in, I would, or is it just iServices? Whatever it was, I think it was iServices, and I'd have a method called add transients, and that's where all my transients would live. Add scoped, and that's where all my scopes live. And then from the name of the method, hey, I'm adding this business logic service, and it's going to be transient, or it's going to be this, it's going to be that. So when you're digging into startup, you're not looking at 5,000 lines of add statements. You're just the relevant.
It comes back to the clean code principle of sort of saying, okay, I'm going to group all my repository registrations together. I'll group all my service registrations. Here's where I'm going to go and do my HTTP client configs, break them all up into smaller functions, and there's nothing to stop you writing a unit test that goes and takes your starter, if they're public, goes and pulls them out individually, says, here's a collection, go and build it, and now do all those things resolve as I expect them to resolve.
Absolutely. I've done a similar thing. It's completely different technology, but I've done a similar thing with when I've used AutoMapper in the past. Whenever I'm using something like AutoMapper, I like to write a test around it and say, because one of the good and bad things about things like AutoMapper, because it uses reflection, is if it fails, it only fails at runtime. There's no way to test it unless you throw a test on it, and then you can run through the tests 1,000,000 times a second and they all pass. Or as soon as they fail, before you've even, right, I've not moved on, I need to stop. Maybe red, green, refactor, or is it tests and commit or revert, so TCR? So then you got a chance to sort of take a step back and go, whoa, what have I broken? Right, I'll go and fix that, Excellent.
Yeah, it'll be interesting to see what you mentioned about using reflection, about the new source generators in 5, as to whether things like that do a lot of reflection start using source generators to actually go and build concretes.
Yeah, that would be interesting, because then that would be easier to test that, wouldn't it? Because then you could physically test it by go and build it. Oh, look, there's the code. Right, read through it. Right, yep, that makes sense. Yeah, interesting. Okay, we have talked about unit tests quite a lot, and we do use. I know for a fact. Unfortunately, I'm a little busy today. We're running out of time, but I would like to talk about when I'm writing my unit tests and I have some kind of injected service. I've got some iService coming in. I know that I want to mock that service. Is mocking similar to dependency injection, or is it just a case of here's a wrapper? I mean, do you know much about this? You may not. The way that I understanding is if I'm using the NuGet package mock MOQ, then that's probably that. All that's doing is it's creating like a proxy instance around it.
Yeah.
And I define what each method needs to do. And if I don't define it, it doesn't exist, and that's null. That doesn't exist, right?
Yeah. So this is back to the inversion of control in that instead of my DI container giving that instance, mock is generating the instance. So, and this is why it's so sort of crucial to have abstractions, be it interfaces or abstract base classes, as the signatures on your constructors, because then your thing doesn't care what the implementation is. It just says, I know I've got that contract and it will do what I'm expecting it to do. So be it your mock, be it your own handcrafted mock, which funny enough, I was doing today. I was writing a whole load of handcrafted ones because I had to do some stuff where I was testing how many times something was called in certain conditions. So I ended up handcrafting one. But because I'd passed in an interface, my DI container would say, oh, here's the runtime thing that goes off and talks to Redis. But I wanted to test that. Well, if Redis comes back and says nothing's here, or something's gone wrong with threading and it's called Redis and I've got a corrupt thing, how do I deal with that? So I had my own handcrafted mock.
It's interfaces and abstractions all the way down, isn't it?
It is.
I have wondered about reading through things like the ASP.NET dependency injection code, because I've got a feeling it's going to be injecting a lot of dependencies itself. Like, at what point do you get down to?
Yeah. A classic one is the HTTP context accessor, which is a strange hinterland of a class in that HTTP context is scoped. But HTTP context accessor allows you to get to the scoped HTTP context from inside a singleton, because it's doing some weird stuff with async context, which is a bit like thread context. Mm-hmm. But it sort of passes it all down. So when it goes off on an async and goes off and does something and comes back on a different thread, it still transfers it to your new thread. And that's this sort of strange hinterland where you can kind of have this thing that gets to us scoped from a singleton, which really does bend your head a bit.
Yeah, I can only imagine just how, because before this conversation, that would have made perfect sense. There is a script over there, and I'm in a singleton, not a problem. But now you're saying, earlier on, you were saying because the singleton, it captures its what was it? Captures its dependencies.
Yeah,
that's it, right? Yeah, so it's captured that dependency. But then, in this instance, the IHTTP context accessor is accessing it from. It's not the captured version. It's
So what's happening is it somewhere along the pipeline, it's putting this HTTP context into the async thread. The async context.
Right, yeah.
So it's sort of gone outside of the DI container and said, it's over here.
Right.
And now anything can get to, as long as it can understand that context. It bent my head when I read through it.
Yeah, I'm sure it would. And it sounds like it's already doing it to me, I have to say. You're describing it, the fully understood version, and I'm like, I don't have a clue.
I don't promise I truly understand it. David Fowler might be listening and sort of shaking his head at me.
Hey, I mean, if David Fowler's listening and he wants to come on and correct me, then that's perfectly fine. I don't mind. Okay, so sort of wrapping up a little bit then, do you have any quick fire tips? I know that before we started recording you were like, I've got loads of tips, but maybe
I could whisper on for hours, Jamie. I could whisper on for hours. So yeah, we've talked about factory and builder patterns. Be aware of when you can use them is a good one. Middleware we touched on. Be aware that middleware is created as a singleton. Use the invoke to pass in your lesser scopes. One that not many people know is that you are not just limited to interfaces and classes with the DI container. You can't register value types. Records you can register, but there's kind of no point. But you could register a factory to generate records. But the one people don't really think about is custom delegates. So custom delegate is effectively a function definition.
Yep.
So going back to our example about date time now. Now we sort of said, well, you could have an interface and have a method of get current date time. So your concrete implementation would have system date time now, but your mocks in your unit test could just say, just this fixed date time.
Yes.
But that's a lot of ceremony of having to go and create an interface and a class just for one method. You could just have a custom delegate that says, I've got this function that doesn't take anything, but it returns the current date time. Just one line. And then in your startup class, in your configure services, you could just have a lambda that says, if someone asks for that function, return date time now. And then someone executes that function in their consuming class and they'll get the current date time. So you've saved having to write an interface, having to write a class. You've just got it with one line of code. Well, 2 lines of code, one to define the delegate and one to register it. So that's quite a nice one. That one leads on. It's on my blog site because it's quite complex to explain, but named dependencies. You can't do them in the .NET Core one, but you can in like the likes of AutoFac, where you can say, I want to whenever I say I've got a dependency called Steve, I want you to go and get one of these. But if I pass in Jamie, I want a different thing.
Right.
You can use the custom delegate that says take a string and then go into this lookup table inside this other class and go and get me the appropriate instance just based on a string.
Sure.
So it's all on my blog site about that because over audio it's very hard to try to describe that one. My last one, as we're short of time, is try not to inject iService provider. So iService provider is the general interface to the .NET Core container, and it's got methods like get service, get required service, things like that. The reason I say that is because it's a service locator pattern, or rather a service locator anti-pattern. So long before we had the frameworks, I talked about poor man's dependency injection, and you had a static class that knew how to construct everything, and that was the service locator. Mm. But over time, that went from being a pattern to an anti-pattern. Now, by injecting iService provider, you're placing the responsibility of your consumer to know how to use iService provider, whereas the consumer should just really say, I want an instance of iBusiness rules, for example. Mm. And when it comes to mocking it in your unit test, if you're having to mock iService provider, you've got to build a service collection. You've got to then build the provider to then pass that in just to go and get this dependency. So try and avoid doing that. Mm. The exception to that rule, the classic it depends, is if you've got a factory or a builder, which may need to use that to go and grab some things at runtime, depending on the appropriate lifetime. Mm. The caveat I put around that is if you've got those classes, possibly make them private inside your startup class, because startup class is a way of iService collection and iService provider. But if you put them inside there, your implementation of that factory that uses iService provider, the outside world doesn't know about it because it's private to your startup class. But if you're exposing your factory through iService factory, mm-hmm. then iService factory will say, I'll go and give you my hamburger. So I should have said iHamburger factory.
Yeah, of course.
but you get the idea of where I'm trying to come from. So yeah, that's my last tip. I have got 101 other tips, but we're short on time.
Well, I mean, perhaps that's an idea for a blog post, right? And then we can link to it from the show notes.
We can do. When this comes out, hopefully I'll have a whole raft of them.
Well, that's a series of, if it's 101, that's top 10 tips for dependency injection, right?
Yeah.
Loads of content.
You've set me a challenge there, Jamie. How many can I get done by the time this comes out?
Well, we'll soon see. Unfortunately, like you said, we are running short on time, but I was just wondering, could you let the folks who are listening know the best way to keep in touch with you?
Yeah, sure. So if you want to keep in touch with me, I'm on Twitter at SteveTalksCode. As we've just said, I've got a blog post at stevetalkscode.co.uk. If you're interested in the stuff we've been talking about, I do a talk. I've been going around the various user groups in the UK. There is a recording of it that I did for .NET Southwest on their YouTube channel, and I'm sure Jamie will put the link into the show notes.
Certainly. Excellent. Well, thank you ever so much, Steve. This is the thing, right? We get together and we talk about one. I say to you, let's talk about this one very specific topic, and we end up going everywhere and then rapidly running out of time. But I think that just shows how much fun it is to get together and talk about these kinds of things.
Yeah, great catching up with you again, Jamie.
It's been great catching up with you too, Steve. Thank you ever so much.
Okay, thanks, mate.
Thanks. That was my interview with Steve Collins about dependency injection. Be sure to check the show notes for a bunch of links to some of the stuff that we covered and a full transcription of the interview. The show notes, as always, can be found at .NETCore.show, and there will be a link directly to them in your podcatcher. And don't forget to spread the word. Leave me a rating or review on your podcatcher of choice. Head over to .NETCore.show/subscribe for ways to do that. And to come back next time for more .NET goodness. See you again real soon. See you later, folks. .NET Core Podcast is a production of RJJ Software.